Hey guys, this is how we're fixing the CrockPot Express, the multifunction, which is also a pressure cooker and also a slow cooker. Had this issue where they stopped working all of a sudden. It was literally in the middle of cooking and then it wouldn't turn back on. We changed the cable, power cable, did not do a difference. We also changed the outlet, no difference. So it made me think that there's a fuse issue. So I bought the replacement from Amazon. I think it's close enough. It's a AUPO BF184 thermal fuse. So this thermal fuse breaks when it reaches a certain temperature, unlike the amperage based fuses out there. So this is a temperature based fuse. So I guess what happened was it reached 184 degrees Celsius somehow. It broke the circuit, which is good news because it protects the rest of the cooker. So I went ahead and bought this particular terminal from Lowe's. I'm not sure if you can see it well. And what I'm gonna do is I'm gonna replace the old fuse with a new fuse, and I'll kind of show you how I'm doing it. I'm sure there's other ways to do it. Trying to keep the costs low and still get a good reliable fix. So this is the connection that goes from the fuse into the rest of the cooker. So what I'm gonna do is I'm gonna twist the wire here. I bought this size, which is 22 to 16 gauge. I think this is around 1 millimeter. I'll stick it through here. As you can see, it's going in. And on the other end, I'll be putting the fuse leg. And hopefully this maintains the electrical connection between the two parts. I'll use a crimper. I'll try this crimper here, see if it'll work. Different sizes, so I'll work my way down. I'll start with the big size, then size down as needed. The idea is to kind of hold the two together and not lose the electrical connection between the two parts. And the idea is to reintroduce the circuit into the crock pot so it can function. Actually, a theory of mine would be that if I got rid of the thermal fuse altogether, it'll work. The problem is it's there for a reason. So, too loose. Let's try again. If this doesn't work, you can just manually crimp it. You just need some sort of way to crush it so that it doesn't slip. Okay. And this did not work either. Looks like it might have damaged it actually a little bit. Again, all I'm trying to do is get a connection, a mechanical connection. So let's see. Let's see what we can do, which tool to use. This is a wire stripper, won't help me. So here we go, let's try just manually crimping it. Try and get a crimp manually. Let's see if that'll work. It does feel tighter already, which is good. So let's see. Bismillah. Takes a lot of power from me. I hear a crush. Okay. Nice. This side is crimped, guys. The wire is connected to the metal ferrule. All we gotta do is somehow see if this will crush onto the solid leg of the thermal fuse. Okay, bismillah. Okay, it's not the best. Yeah, might as well give it a couple more manual crimps just to make sure it doesn't slip. Use some muscle. This would be better and easier if you had the right tools. This is just kind of what I had to kind of figure out to get it done, and hopefully it'll work. Okay, good enough. I mean, it's not moving. So there you go. This is one part of it. Like I said, we connected the TF184 thermal fuse. This is the side. Let me bring this closer. Okay. So this is the side that comes. So this comes from the power outlet. This is the power outlet. The red is hot. Goes into the thermal fuse. Goes into this connection that we just did, which will in turn connect here in this prong with the remainder of the connection, which is right here. So yeah, I'll disassemble this one, and then we'll do the same thing to connect this guy, the thermal fuse, with this section of the wire, which will be interesting. But we'll get rid of the old one. We'll strip this. I'm just manually doing it. Again, with the right tools, things are easier. Always invest in the right tools. Hopefully this is a direct job, so I'm not sure if I'll pause the video or not, but I'll go ahead and do it while it's recording in case it comes out good. Might speed through it. We'll see. Try to maintain the wire strip by opening up the ferrule. So as you saw, this is a little messy, but the idea is to get that stripped wire section out. And you saw their double barrel ferrule is what was holding it in place. That would be the ideal tool. One part of the double barrel ferrule goes into the thermal fuse, the other barrel crimps onto the stripped section of the wire. However, making do with what I have. Sometimes you gotta do what you gotta do. Alright, let's go. So my previously connected things are here. I'll try and the sleeve came with it. I will try to put it over everything to insulate it, to protect it. That will definitely be a nice thing to do. We shall see if I'll be successful or not. I know I can do it. If maybe I put this here first. Maybe this goes here first. The rule of thumb, you don't want to keep any exposed. Okay, yeah, I can do it this way. You don't want to keep any exposed metals in your things. That's why everything's insulated. You don't want to be creating your own shorts as part of this fix. Really, it's a very simple fix. I'm just kind of showing it step by step so anyone can go ahead and fix it themselves. The idea, guys, is to not spend money when you don't need to buy a whole brand new cooker when your cooker is already functioning and it's just a thermal fuse issue like mine. Again, this is kind of work in progress right now. There's 100 ways to improve upon this. I'm 100% certain about that, but gotta start somewhere. This is nice. I'm liking it. The thing is being held together. Can't ask for more. This guy, one trick I learned is you can always splice it to make it bigger and kind of carry it over the sleeve here. Let's see if I'll need to do that. I hope I don't need to do that, but if we're gonna need to do that, then we'll do it. No biggie. It's just the sizing of everything. Yeah. Let's do it. Hope my wife doesn't mind. I borrowed the kitchen. The kitchen's scissors. Like I said, we were just splicing it a little bit just to make it open up more. And then once you do that, you're able to increase the diameter effectively and get it over your part, as you can see, and then hopefully it'll act as a lead in. We shall see if that works. I really want it to work, but if it's not gonna work, it's not gonna work. Let's see, let's try again. Like I said, this is a big lead in now. Other thing I can do is I can just cut a little bit of this guy. So this is heat shrink actually. That's why it's this big and it'll come down to a small size. Thing is, another potential fix for this whole guy is to solder it. I'm not sure how these thermal fuses work. Have not encountered them before firsthand. I could have spent the time to research them better and figure out exactly how they work and so on. I think these were crimped initially for a reason though. Um, Maybe to make it easier to repair, but my main concern is that heat will affect it negatively. Um, I quickly looked it up, its specs, and 184 is like the temperature where it cuts off, but there was a different temperature lower than 184. I think that's when it starts kind of like triggering it or something along those lines. Like I said, I can't speak in detail and in depth to it because I'm not an expert on that. Um, but yeah, I'm just trying to avoid heating up my thermal fuse. So I don't want to put a heat gun next to the thermal fuse. I don't want to solder next to the thermal fuse. Just want to try and recreate what the machine, the factory, sorry, had this cooker look like initially. Alright, this is a little worrying, not gonna lie. But I will just go ahead and cut this. Seems like I scratched it from the surface on that black part. Can check continuity real quick. It's functioning, which is good. So hopefully that didn't affect it. I might need the sleeve, honestly. Let's see. I'll just slide it over here. Oh, I did not buy electrical tape. Kind of relied on this guy. On this sleeve. So as you saw, I did lose some strands, and just to make myself less anxious, I will strip a little bit more of this red jacket. Yeah, this looks like it was a mistake because you can see it's taking much longer than it should. Never a good thing when you're working on something like quick and easy like this. Basically what I'm trying to do is I'm trying to get it to the perfect length for my part. Which, as you saw earlier, the other one was just good from the get-go. These wires are very frail and brittle, and they're breaking quickly. So just a heads up, if you're gonna work on this, be aware of that. And honestly, there's a lot that got dropped down here. Far from ideal, I'll tell you that. I'll be the first one to say it. Far from ideal. Far from ideal. And perhaps I'll try and vacuum it after this. This guy just needs to be more cooperative. Almost there. I mean, this actually will work. This actually will work. But it's a little bit longer than what I wanted. I do not want any exposed stripped section off the cooker. I'm trying to think whatever triggered the thermal fuse to fail. Whatever triggered it to fail in the first place can trigger it again. So I might actually need to come back and redo all of this again. Definitely not what I want. Definitely not what I'm looking forward to, but I already started this methodology and I'll stick with it, which is a quick and easy fix. As you can see, that's where hands-on experience comes into play. I know how it's done, just haven't done it before. Some technician you'll hire, for example, if you find a technician who's willing and able to get this job done, they can do it and do it faster and cleaner. I don't doubt that at all. It doesn't bother me because I know if I work on this more and more and more, I'll be better at it. Okay, I think I'm gonna call it. I'll just crimp it this way. Bismillah. Far from ideal. Far from ideal. It's okay. Where's my other piece? This guy. Get him in here. Oh, seriously. This is a little bit too short. I want to cover this piece, but let's just focus on the crimping for now. And just so you know, one good thing when you're working on parts like these is just take a video or a photo before disassembling anything. So I have that. You can always go back to it for reference. And here we go, we're good. So I'm just gonna slide this over. Seems like I can just pull this down a little bit. I just need to maintain the the electrical connection. It will be nice if I can get this guy down a little bit. I don't want to break any more wires. Done enough harm here. Let's see. Not far from ideal. Remember, this is far from ideal. So what I'm doing is just opening up the jacket again, try and get it, slice it over. Try and make things a little bit better, as much as I can. But so long the thermal fuse is functioning, that's my job today, and I think we're gonna be okay, guys. It's far from ideal, but it's not ideal either. It would not be ideal if it doesn't work after all of this. I'll tell you that. This was not smart. Man, only if I had electrical tape, which I should have bought. Not sure why I didn't buy it. Live and learn, guys, live and learn. I don't want this section to be uncovered. So I'll stop the video here and I'm gonna clean up, assemble it, and then maybe show you the end, how it looks like. So I have it on the continuity. I assembled the thermal fuse to the two portions of the red wire, and now we're gonna check it. I'm gonna probe one end of the red wire, and then the other end is the one closer to me here. I'll probe it real quick with the multimeter and let's see what that comes out to be. We're good, guys. We have continuity. Therefore, I'll just put this back together how it was. Basically, this guy is gonna be here. There's gonna be a screw that will hold it to this end that feeds it into this module. So, mission accomplished. Moment of truth here. We'll plug it in. Can you plug it in? We'll see if it comes back on. Here we go. We're good.